This title tells us we'll be learning about using Sklearn, a popular Python library, to check how well a machine learning model performs. The key here is stratified sampling, a technique I'll explain later to make sure our data is fairly represented. The core problem. I need to assess a machine learning model's accuracy using a method called five-fold stratified cross-validation. Think of it like testing the model 5 times with slightly different data each time, ensuring each test has a similar mix of different data types. ML stands for machine learning. This is the question. I'm looking for the best scikit-learn functions to perform that 5-fold stratified cross-validation test. Option A uses "k-fold", which divides data into 5 parts but doesn't guarantee a fair representation of different data types in each part. "cross_val_score" is a function that measures the model's accuracy using the folds created by "k-fold". Option B is the one that uses "stratified k-fold". That's the key. This divides data into 5 parts, ensuring that the mix of different data types is similar in each part. Again, "cross_val_score" calculates accuracy. Option C uses "shuffle split", which randomly shuffles and divides data. While helpful for cross-validation, it doesn't guarantee similar data mixes across parts. "test_size equals 0.2" means 20% of the data is for testing. Option D uses "group k-fold", suitable when you have groups within your data that you want to keep together. This is not the right tool for this problem. This quiz tests your understanding of different cross-validation techniques in Sklearn, a popular Python library for machine learning. I'm focusing on how you pick the right tools to reliably evaluate your model's performance. We want to split the data into 5 groups, folds, for cross-validation. Importantly, I want to make sure each group has a similar mix of different data types, to prevent bias in model evaluation. Stratified means that the proportion of each class, the categories of the data, are evenly distributed across those folds. I'll need a method designed for this. The goal is to reliably assess how well the machine learning model performs. Cross-validation lets me train and test the model on different parts of the data, giving a more trustworthy idea of how well it generalizes to new, unseen data. This will help avoid overfitting. The problem involves a dataset with 100 samples. This detail helps you choose the appropriate techniques. The size doesn't directly dictate the cross-validation method, but it's an important piece of information. I'm evaluating a machine learning model's performance using a dataset with 100 samples. I want to use 5-fold cross-validation, which means I'll split the data into 5 groups, folds. Crucially, I need to ensure that each of these 5 folds has roughly the same proportion of different classes of data. This is important to get an unbiased evaluation, otherwise, my results might be skewed. For example, if I'm classifying cats and dogs, and one fold has mostly cats and another mostly dogs, my model's performance scores won't be trustworthy. This option uses "k-fold", which simply divides the data into 5 consecutive folds. However, "k-fold" doesn't guarantee that the class proportions are the same across these folds. That's why I won't choose this option. It's not stratified. This uses "stratified k-fold", which does maintain class proportions across folds. This ensures my cross-validation results are more reliable, so this is a great choice. "cross_val_score" is a function that helps me calculate performance scores efficiently during cross-validation. "shuffle split" randomly shuffles the data and splits it. While it does create multiple train test splits, it doesn't ensure the same number of samples in each fold, nor does it guarantee that class proportions are balanced in each split. This is not ideal for my needs. "group k-fold" is used when I have groups of related samples. I want to ensure that samples from the same group are not split across folds. However, I haven't been given any information about sample grouping in this problem, so I'll skip this option. This section's title tells us we'll be choosing from several scikit-learn methods for splitting data to evaluate a machine learning model's performance using cross-validation. It's all about choosing the right tool for the job. I'm given a dataset with 100 samples and need to choose the best way to split it into 5 folds for cross-validation. The crucial part is maintaining the proportions of different classes within each fold to avoid bias. This is important to get reliable results. Option A suggests using *k-fold* with 5 splits and *cross_val_score *k-fold* simply divides the data consecutively, but it doesn't guarantee that the class proportions will be similar across the folds. Therefore, this isn't the best option if you want to make sure the class ratios are maintained. Option B uses *stratified k-fold*, which is specifically designed to maintain class proportions across folds. It does this stratified sampling. Coupled with *cross_val_score this option will give fair and unbiased evaluation results. This is exactly what I need. Option C uses *shuffle split*. While *shuffle split* shuffles and splits data, it doesn't guarantee equal-sized folds or maintain class proportions, meaning it might not fairly represent your data. This is a suboptimal choice. Option D uses *group k-fold*, which is used to handle grouped data, ensuring that samples from the same group aren't split across different folds. Since this isn't relevant to the problem description, I don't need to use this method. This instruction is the quiz question itself. I need to choose the best method among the options given. This tells me the size of the dataset I'm working with. This dataset size is relevant to the problem. This quiz tests your understanding of Sklearn's cross-validation techniques. We'll explore different methods for splitting data into training and testing sets to evaluate machine learning model performance. It's all about making sure your model's evaluation is fair and accurate. Imagine you have 100 data points and want to check your machine learning model's accuracy. We'll split these points into 5 groups, training your model on 4 and testing on 1, and repeating this process until each group serves as a test set. The catch is, we need to keep the proportions of different data types, classes, the same in each group for a truly fair test. This is the best approach. Stratified k-fold ensures that each of the 5 folds has similar class proportions to the original dataset. *cross_val_score then conveniently calculates the model's performance across these folds, giving you a reliable estimate. Think of it as a more thoughtful way to divide up the data than just chopping it into pieces. While *k-fold* splits the data into 5 groups, it doesn't guarantee that the class proportions remain equal in each fold. This could lead to a skewed performance evaluation, particularly if your data has unbalanced classes. It's like cutting a cake without paying attention to the frosting distribution. You might get uneven pieces. *shuffle split* randomly shuffles data and creates multiple test splits. It doesn't guarantee equal-sized folds, nor does it maintain class proportions. It's great for some situations but not ideal for our problem's strict requirements. *group k-fold* is used when you have groups of samples that must stay together during splits, e.g., patients from the same hospital. Since we have no such grouping here, it's not relevant to this problem. Option B is correct because it uses *stratified k-fold*, which is the perfect technique for maintaining class proportions across folds, as requested in the problem statement. Incorrect because it does not guarantee stratified sampling. Incorrect because it does not guarantee equal-sized folds or stratified sampling. Incorrect because *group k-fold* is only necessary when you have data groupings that need to remain intact during the data splitting process. I'm tackling a problem about evaluating a machine learning model using Sklearn's cross-validation tools. We're using a dataset with 100 samples and aiming for 5-fold cross-validation, ensuring that class proportions are maintained across the folds using stratified sampling. This is important to prevent bias in our model's performance evaluation, especially if we have an imbalanced dataset. This section presents the core problem. I need to identify the correct Sklearn tools that perform stratified 5-fold cross-validation. I'll look at several options and pick the most appropriate one. This is the question that sets up the quiz. I will assess different options for 5-fold cross-validation that preserve class proportions using stratified sampling and select the appropriate ones. This option uses KFOLD, which performs simple k-fold cross-validation, but it does not Guarantee stratified sampling. The class proportions might not be maintained across folds, so it's not the best choice for our problem. This is where we use stratifiedkfold, which is specifically designed for stratified k-fold cross-validation. It's perfect, because it maintains the class proportions in each fold, addressing the key requirement of the problem. I'm using CROSSVALSCORE to evaluate the model's performance. Using SHUFFLESPLIT means I'm randomly splitting the data into training and testing sets. While this can be used for cross-validation, it doesn't guarantee equal-sized folds and it doesn't stratify the data. Therefore, it's not suitable for this problem. Here, I'm using GROUPKFOLD, designed for situations where samples are grouped, and you want to keep samples from the same group in the same fold. Since this problem doesn't mention sample grouping, this option is not relevant. I'm working with a dataset consisting of 100 samples. This is relevant for determining the appropriate size of folds and affects the overall evaluation process. The problem specifically requires a 5-fold cross-validation. This means splitting the data into 5 folds. 4 folds will be used for training, and 1 for testing, and this process repeats 5 times so each fold gets a chance to be the test set. Stratified sampling is crucial here. It ensures that the proportion of each class remains roughly the same in each fold. This is particularly important for preventing bias in performance estimates, especially when dealing with datasets that have an uneven distribution of classes. It helps provide a more representative evaluation of the model. I'm using Sklearn, a powerful Python library, to perform cross-validation, a technique to evaluate how well a machine learning model generalizes to unseen data. I'll be choosing the best method for this task. I have a dataset containing 100 samples, the individual data points I'll use to train and test my model. I want to use 5-fold cross-validation. This means I'll split my data into 5 groups. Each group will be used once as a test set, while the other 4 groups will be combined as training data. To ensure fairness, I'm using stratified sampling, ensuring each group maintains the original proportions of different classes in the dataset. I'm determining which Sklearn function is best suited for my stratified 5-fold cross-validation task. Option A uses "k-fold", which divides data into folds but doesn't guarantee that the class proportions are maintained in each fold. "cross_val_score" is a general function to get cross-validated scores. Option B uses "stratified k-fold", which is specifically designed for stratified sampling, maintaining class proportions. "cross_val_score" will calculate the scores across these stratified folds. This is the correct method. Option C uses "shuffle split", which randomly shuffles and splits data. This doesn't guarantee equal-sized folds or stratified sampling, making it unsuitable for my problem. Option D uses "group k-fold", which is used when data has groups that shouldn't be split across folds. I don't have such groups, so this isn't applicable.